Over the past 25 years, Dr. Khazanovich has been involved in various aspects of pavement research, design, and evaluation, including performance prediction modeling, non-destructive testing, and finite element modeling. During development of ASHTO, Mechanistic Empirical Pavement Design Guide, he served as a member of the Rigid Pavement Leadership Team, responsible for structural modeling of rigid pavements and overlays, development of neural networks to predict critical structural responses, subgrade characterization procedures, and development of faulting prediction. His papers have received awards from the Transportation Research Board and International Society for Concrete Pavement. Dr. Khazanovich, thanks so much for joining me today.
Thank you for having me.
Yeah, of course. So, today's topic, of course, is LLM applications in transportation research. And just going through your bio, there's a couple aspects of that come to me as being very relevant to this idea of LLM applications. And we'll get into all that. We'll get into all of the ways that you're using these technologies in your projects with the Smarter Center. But just to begin this conversation, I wanted to talk just about your sort of kind of early experiences with large language models. I feel like everybody who's used them at this point kind of had a moment of surprise or kind of amazement at a certain point. So just tell me a little bit about what your introduction to this technology was as a scientist.
Okay, well, mm, it's interesting that my undergrad study was in Russia, and my first term projects I performed using a slide ruler. Many people don't even know what it is right now. But later, during my PhD study in the United States, in the University of Illinois, I was introduced to machine learning and like neural networks. And, and machine learning really fascinated me. It's never been the major direction of my research, but I was always been involved within applications of neural networks one way or another. And when we in the end of 1990s, when we worked on the development of the mechanistic empirical payment design guide, we actively used neural networks to develop models that still used in design of concrete payments. And for the best of my knowledge, it was the first design procedure, at least in civil engineering, that actually utilized neural networks. So machine learning is not new to me, but actually, I still remember the moment when I was introduced to OpenAI. And here it's another important observation. Professors uh, thought that they teach students, but actually, for me, the most exciting part of our job is an opportunity to learn from my students. And I was blessed with great students over my academic career. And one of them showed me an OpenAI when they have a ChatGPT when it was just released, maybe a month later. And my first reaction was, it's just a toy, it cannot be serious. And I asked ChatGPT to write me a 14 program for um, um, developing a stiffness matrix for computing a stiffness matrix with beam on Winker Foundation. And when ChatGPT produced that code and I checked it and it was correct, that convinced me that there is something there. And that changed the direction of my research. And now about 50% of my research deals with the use of generative AI for transportation application in general and payment problems specifically.
Absolutely. So was it that kind of multimodality that kind of cracked open this technology as a potential tool for you, the ability to kind of weave between text and code and maybe even images?
It's a great question because initially I, I can explain what fascinated me because I
Mm,
knew that it's something very exciting. But when we start experimenting with it, but it took us about 3 or 4 months before we actually found the first problem where it was really useful. It was not just a toy. It was not just an exciting tool, but something useful. And that problem was when we analyzed um, the Department of Labor database of um, construction of highway construction accidents. So the Department of Labor maintains very comprehensive database of any incident that resulted in hospitalization or, God forbid, death. And they collect very extensive information, but it's very difficult to analyze it because there are so many factors affect, like well, so many factors lead to accidents and so many different outcomes. So and the database contains comments, descriptions of what actually happened those accidents. But frankly, those comments were rarely used because you have to read thousands of descriptions and try to make sense of them. And we kind of entertain an idea that use an OpenAI to summarize and categorize this accident and to learn from it. And that, for the first time, led to the quite exciting results. And that's really sad. But the short answer, yes, it's a tool that actually changes the world. So it's for its ability to summarize the text, to generate images, to write codes, to interpret results, to generate ideas. It's an extremely challenging tools because when something generates, some generations are good and some generations are bad. So that's what's also important to remember. But again, it's a new world now.
Yeah, I definitely want to dig further into this kind of qualitative data categorization aspect because it's something that has come up in your work with the Smarter Center, of course. But before that, I kind of want to continue mapping out this kind of jagged frontier of LLM capabilities, specifically as it relates to your research. So you've done that a little bit. You've described what it's good at and how you use it when you're working with your PhD students. Where are the areas that it kind of falls flat beyond its kind of hallucinations, or maybe that is the core of it. I know you and I have discussed the fact that it will just make up citations sometimes, but there are also context issues among other things. So, what does that frontier look like for you? Where does it fall flat?
Well, it's it's important to remember that generative AI is just a tool, and in and there are two ways to deal with this. We can fight with this. For example, we can prohibit you in using it in our classes and penalize students for using it, or embrace it and make sure that it's used um, uh, responsibly. And like last year, I gave an assignment in my finite element class to generate a question to ChatGPT or Gemini that produces an answer that looks legitimate but is completely wrong. So and I got a large number of very creative responses. But I just give another example. We asked ChatGPT what was the first building built from asphalt, um, and it gave us the exact address, the name of the architect. So the results looked legit. So it was very creative, but again, not correct. I'm not even sure that this is exactly hallucination, but technically it
Mhm.
is. But the bottom line is, it's a tool. It's a powerful tool, but if it's used without proper checking, so it's then it can create a lot of harm. It's number one. And the second is, it's I would not, maybe it's incorrect to say it's not a tool. It's a set of tools. So, for example, for if you were trying to use it for helping generate code, for computer program code, then some tools are better than others. If you're using for summarization, then other tools. Now, extracting knowledge with documents, you have to use different tools. So so basically where it's not necessarily limitations of the tool itself, but it's our limitation understanding what the limitations are and using it appropriately. But uh, this is a rapidly developing field. The limitations that were identified 2 years ago basically don't exist now. So I would not, and since this presentation may be viewed like several years later, I would be hesitant to point out any specific area where it is flat because it might be addressed tomorrow. But what is absolutely clear that the chat GPT or generative AI will not eliminate the need in engineers, but it will even erase requirements for qualitative engineers because
Mm.
everybody can ask ChatGPT a question and get an answer. Only a few people can interpret if the answer is correct. It's another part, only the way how we formulate questions, what we ask, what tool we ask, that will be more important than actually really, just just an ability to ask questions, let's say, an availability of those tools. Yeah.
Sure, sure. And just as kind of a follow-up question to that, this might seem like a kind of mundane point, but I feel like um, LLMs are really like a supercharged tool for literature reviews because the corpus of literature is just getting so massive that having this tool to excavate and sift between all of the knowledge seems like particularly useful. And while while the hallucination issue is a problem there, that is something that can be kind of filtered out rather quickly. It's like, okay, this isn't relevant. This isn't real. So when I use it, that seems to be the best use case. It's kind of like an advanced Google Scholar assistant or something like that.
Well, I'm glad that you mentioned Google Scholar because I remember the time when we had to go to the library and even with the computer we have to spell exactly the title of the paper to find it. Now, and generally looking for a paper involved like screening a large number of documents that were completely irrelevant. That's what Google Scholar helps us to identify the documents that are most relevant. And you're absolutely right. Generative AI can be used as a screening tool and summarization tool. It's a great ability. So we just recently um, uh, submitted a draft of paper to the archive, so it's available from the archive. That when we screened all the engineering papers published by the National Academy of Science and generated an like bird view um, um, picture of what was published over 20 years. To do it in like manually would take tremendous resources. And my students develop the tools that help to atomize this process. But still, it's very important to remember that this is just an assistant, just a tool. So we don't want to have it completely atomized. We don't want the literature review be conducted for us. It should automate the routine and mundane tasks. But the final decisions, final learning, this final observations must be done by a person. Otherwise, it's just cheating and basically useless exercise to begin with.
Mm. You've kind of started laying out this framework already, but you know, what is your elevator pitch for what professors and researchers should be doing right now? Like you seem to have developed your own sort of internal code for like what should and should not be done by researchers themselves and what should be kind of given over to the AI research assistants. So like what does that look like very concretely to you?
Well, first of all, if you haven't been using generative AI or used only, let's say, ChatGPT, learn how to use it, embrace it, become proficient as much as you can. So it's and it but the most important is to find appropriate applications and appropriate tool among this open generative AI and like now a huge number of tools. The second is identify what's important to you. For example, if you're dealing with data that kind of have some privacy issues, restrictions, let's say, do not send it to OpenAI or Gemini because you don't know where it will end up and how it will be used later. So in this case, but it doesn't mean that you shouldn't use generative AI, just use local open source models. So basically invest some time in finding appropriate tools, invest time in finding appropriate problems, and build your skills on how to use it. So there is no one advice that will work for everybody. Every researcher has to find his own path.
Understood. Well, let's see how you're using this in practice, right? So I think now is a good time to pivot to discussing your smarter project, which is, operationalizing these very ideas that we've been discussing over the past few minutes. I will take a quick moment to mention that our audience members can use the Q&A and chat functions to ask questions to Dr. Khazanovich that I will then relay to him, and I encourage you to do so. So, Dr. Khazanovich, would you just kind of introduce us to your projects that use LLMs with the Smarter Center? What are you trying to accomplish, and how are LLMs being used to help you achieve this goal?
Okay, well, first of all, I've been involved in the problems related to payment management system development of various performance prediction models that required to manage payment systems better, designing payments for more than 35 years. But what always bothers me that the way how we incorporate users' feedback in these requirements, it has very limited. So it looks like one people collect feedback and one people manage the systems. So and there should be a better way to do it. And I would like to remind the audience that the first national design procedure was based on Ashtar road test when actually the users were driving over the road test and rated the right quality experience. And that was used to generate empirical models and quantify the performance. So these days there are better ways to do it, and we tried several approaches, and eventually we decided to apply generative AI for an analysis of public comments. And we use in two ways. First, kind of to summarize and to develop better understanding of general trends, what bothers payment traveling public, what kind of improvements they would like to see, and we apply it on a regional scale. We use the database collected by the I believe it was PennDOT, but it was subsections by South Pennsylvania Commission. So basically it's a big region in Pennsylvania, and we analyzed about 1,000 comments, a little bit less than 1,000 comments, and we divided in various groups, and we identified that to my surprise, a significant portion of complaints comes to payment conditions, but not all of them were classical payment conditions. People complain quality of bicycle lanes and the way how streets are organized and so on. So it's an interesting experience and an ability to get the big picture out of this, out of thousands of seemingly disconnected comments submitted by various people, at various locations. Some of them from affluent communities, some of them from inner city. It was an interesting experience, and I believe to perform a similar activities that we've done manually would take enormous resources, and actually it will be more subjective than it was done by generative AI. So that was at least my interesting observation. And the second approach we took, just okay, we have this data, but how to help the decision makers to use them, to use them in practice. And of course, the first task the commissioners will do is categorize these comments and just identify what comments refer to safety hazards and or require like strategic investments, what comments needs to be addressed to local agencies and like PennDOT or city or county, and what comments maybe just should be ignored. So, but it's very important to point out that that we envision that our tool will not make any decisions. It will help to make a decision. It will prepare the information. So it will free up a person who will analyze them later from mundane tasks and kind of develop some recommendations. But the final decisions will be made on by person, not by a computer, because you can't foresee all the circumstances and all other constraints that we don't have, like budgetary constraint, political constraint, and on and on. So that's these are the two directions that we took, two task projects, and I believe we produced quite useful results based on the early feedback we got from our work.
So I want to dig in a little bit more to that first task you mentioned,
Yes.
the identification and categorization portion, right? Because you're taking all of the kind of messiness of human language. I believe with these all submitted via email or some sort of like, was it all text?
So, well, the way the way how database is collected, it's collected with various ways. Majority of comments are submitted to the website, but some of them were collected during town hall meetings. Some of them were sent by emails. Yeah, so basically the
Okay.
various. Yeah.
So the messiness of human language in a variety of different contexts, nonetheless. So I imagine, you're dealing with different emotional valences, different edge cases, different speakers, and things like that. It's a lot of qualitative kind of squishy data, and it's being evaluated by a machine learning model. How do you evaluate its effectiveness in kind of managing these ambiguities, I guess, in language? I'm kind of curious. Do you think it does a good job or?
Well, actually, it is an excellent question, and I would say that the LLM did a good job, but maybe we didn't, at least initially, didn't do a good job. So because it's and the way the process how we've done it first time, it still required a lot of manual evaluation, verification, and sometimes rearrangement. Because even as you said, that determination of a number of categories, it's still a extremely difficult task. It's extremely subjective task, and LLM doesn't do it really well. Although I hope we're improving it now. But starting from begin this in terms of like emotions. Actually, that is one of the advantages of LLM. It doesn't get offended. So it kind of it allows like to filter out just the emotion and emotions and maybe like certain bias in the results. Because eventually, on if you look at each individual comment, then yeah, this might be subjective, might be emotion. But if many people complain on the same subject, that it means that there is something there. So that and that's what LLM is really good at, is kind of summarizing information, extracting major knowledge. But the way how we've done, we first divide them into large number of bins, and after that went individually through these bins and decided, well, maybe they should be rearranged because it's more similar than LLM thing, and some of them are not so similar. Although in this case, for example, if people complain on a sidewalk, but in one case it's related to quality of the way house was built, another that there is no sidewalk or it's too narrow or whatever. It's a different issue. So basically, it shouldn't be in one category. So uh, we still learn how to do it better, but uh, but without any doubts, we can conclude that um, even if it's not perfect, it dramatically improves productivity and it performs and permits the person who makes the decision concentrate on the important issues and not on routine and like reading of frustrated messages.
Right. I'm not surprised to hear that it's relatively effective at parsing human emotions and dealing with the context related to that. J Simply because LLMs have become so popular as these kind of strange personal therapists. And, maybe that's because they're not exactly like objective per se. I don't know if that's the right uh, word to use in this context, but they're certainly dispassionate. And as you artfully put it, they don't get offended, right? Um, and they're more free from the kind of human and institutional biases that we're more used to. And maybe in that way, they're kind of a check on our own biases and the biases of our institutions. But
Well, here I would be
yeah,
careful because they're they're free from certain biases, but they introduce new biases.
correct. Yes,
Just
absolutely.
just I give an example that's completely politically correct. Uh, in Since there is more information on the web about uh, asphalt payments than concrete payments, if you ask uh, if you ask um, um, generative AI, like let's say ChatGPT, an advice for what kind of payment to use for certain conditions, it will more likely recommend you um, an asphalt payment than concrete payment if you don't ask specifically. It's like if you don't mention concrete payment specifically, because it's kind of biased toward asphalt, not intentionally, but because there is more information there. So,
Mm,
and there are similar other biases we should be aware of. But again,
absolutely.
objectivity is
Bias in the
subjective.
training data.
Yes.
The OpenAI asphalt conspircy.
Yeah. It's not conspiracy. It is what it is. But the beauty of this, it can be evaluated.
Mhm.
It doesn't. But at the same time, you can introduce your own bias if you ask certain questions over and over. Then we don't know what happened. Again, here I'm just purely speculate, but you don't know what information uh, like such Google or OpenAI collect on you, and they might
Mhm.
feed you with certain information, like it happens in Google search. So
Sure. You don't even
advertisement.
need to go that far, I think, because the sycophancy issue in LLMs is very widely discussed. So I imagine, the pitfalls for this as a researcher would be something like it's encouraging you to go down a line of inquiry that may have already been thoroughly addressed, or maybe it's just not that insightful or useful. So that is certainly something to be mindful of as well.
Here I would like to also point out that it mm, it is believed that if you use an API instead of chat box, you can specify that just start from scratch. So it's you have a little bit more flexibility to there. Although again, I in this case we assume that we can trust 100% what's said. But if this is a concern, then use open source local large language models, and in this case, you are in control what's there.
So on that note, let's switch to the sort of second task of the project. We have our data that has been collected and categorized in this sort of recursive process. Now, how do you operationalize and visualize this information and make it concrete? So how do you take my angry phone call that I left and turn that into actionable data for policymakers?
Okay, well, first of all, it's our vision that we will uh, perform this characterization on the fly, and in certain cases it should be actually immediate recommendation should might be not to call transportation agency but call 111, or that's because it's emergency. Don't some emails will not be even read for several days, so that all phone calls won't be answered for several days. So that's number one. But what we've done so far, we developed a tool that is currently under testing. So a person takes the comments. In this case, we've already done it with the previous set of comments, and now it will be tested on a new set of comments, and will and it uses a large language model to characterize the responses, to group them, and to summarize them into like one that and generate one dashboard. But basically, it mimics routine tasks that was done before, but um, it will still allow the person to go and check, especially for the most important comments, if they're done correctly or not, and regroup them and recharacterize. But so far, we got very uh, uh, positive feedback. And the bottom line is the tool that we're developing might be sophisticated, but the use of this should not be difficult. So
Hmm.
it's still a practical engineer should be able um, to, to to use this tool without any significant training. It's still good. It's like in this case, it's all open data. So we used Gemini's tool, so it requires the user Gmail and set an account with Google, but that's the only requirement. The rest is done um, by our program, and it's kind of doesn't require any generative AI knowledge from the user. So, um, but um, but very significant uh, mm, like uh, analysis is done like behind the screen.
Hmm.
So,
And as your
so again,
preliminary,
the idea is to make these results implementable, so it's not something that can be used to publish a paper and put on the shelf. Yeah.
right, right. What is that? Does that look like a map? Does that look like a dashboard? Like what helps? What's the interface, right, for policymakers?
Well, it's the interface. Well, first of all, it's a computer program, so it runs on the computer, and the user import the database. It's like in this case, it's CSV file with the data, and it generates the output and generates summaries of the results. So that's and it's quite adaptable. So the user generates its own criteria, how he would like to characterize the project. For example, in our case, like it's a bridge project, it goes into one category. If it's a safety related issue, it's another category. So it mimics what people do, what people done in the past, but at the same time, it's flexible enough to be able to modify it for uh, slightly different needs. But uh, one limitation that we hope to address in the follow-up study is currently there is a very little efforts were made to close the loop. So after the comments are categorized and uh, kind of referred to appropriate agencies, or the decision was made uh, to let's say develop start a major reconstruction project and on. There is very little efforts is made to go back and see for all the comments if they be addressed and when, how quickly, and so on. So there is no learning curve from this side. Partially because it would require significant efforts. There was not enough resources to do it, and we hope that we will be able to provide a tool that kind of help to close the loop. Again, it's up to agency to close the loop or not, but it will help. It will make it less uh, time consuming and effort consuming. There is another application that we would like to explore, and actually, and currently we're working on this tool for different sponsor. Uh, it's improve the quality of the input data, because currently when a person provides an input, sometimes angry input, as you said, because he is frustrated, uh, it's the person is not an engineer, it's not an expert in transportation, so he may not provide the most uh, uh, the complete information.
Articulate.
Yeah, the articulate help. So basically, if the ability to ask follow-up questions, that's what LM can do. So and a person may have it, this information may not, but at least if this information is available to then it will be provided, and that will naturally improve the quality of responses. Better information you have, better you're able to address the problem. So that's this flexibility of generative AI tool. It's not that it's not you have to give a chance not to select of predefined categories, but to be flexible in what's follow-up questions. Because it's still underexplored, and it's a challenging task, but hopefully we're making progress on this.
Mhm. And, in your analysis of those roughly 1,000 responses, what were your main takeaways from the citizens of, I believe it was Pittsburgh? And I guess the reason I
Well, it's
ask
area
is,
around Pittsburgh. Yes, it's a large area, but it's around
sure.
Pittsburgh was a part of this. Yes.
Um, I'm kind of wondering what your major takeaways are, because I'm kind of curious, is this purely an automating task, or were there novel insights derived from the LLM that would have been difficult for humans or a team of humans to come up with, do you think?
Well, I would. Well, in this case, our job was kind of um, to summarize what's there. So
Hmm.
we didn't, and I don't think we found something that is kind of dramatically uh, unexpected. But um, what was we performed like is interesting analysis that would be again not difficult but time consuming performed by other means. We divided all the comments based on the area to which uh, it refers to, and categorize it in like affluent area, low income area, middle income area. And it's interesting to see that basically, regardless of of the kind of affluence level. Again, I would like to point out, not people who submitted comments, but for the area where it's located.
Hmm.
Uh,
Zip code,
it's
sure.
yes, it's a basically concerns were very similar. So people want to have better transportation. They want to make sure that on residential streets there is no speeding. So well, of course, certain areas people complain that there is no sidewalks at all, and in certain areas people complain that they're not smooth enough for bicycles and so on. So there is a difference, but it's not as dramatic as kind of you would expect. So it's not like one area can completely dis yes, repair. So because, which means that we're doing a good job, at least trying to make it like uh, um, accessible and available for every transportation user.
Do you believe that, sorry.
So, sorry, and of course, some comments going back to maybe unrealistic. For people complain that there is a need a better rail service with certain city. Well, it cannot be addressed immediately, but again, it's interesting that people complain about this.
Hmm. Um, Turning away from your project and towards maybe speculative approaches or your own future research, do you feel like there are subfields in transportation or even pavements that you feel have been underexplored with respect to LLM applications or even machine learning applications more broadly?
Uh, well, mm, well, in general, like LLM and been introduced relatively recently. This technology is less than 10 years old, and half of this time it was like only a very narrow group of experts were even like working in this area, were aware of this. Before ChatGPT was introduced and explosion in this area happened, it was not uh, like widely used. So in this case, basically the entire transportation area is up for grabs. When we submitted our first RB paper on LLM, we were one of like I believe about 10 papers, give or take. Next year, last year it was uh, like about 100, a little bit more than 100. I don't remember the exact number. And we expect many, many more papers this year. And generative AI is here to stay. So basically, almost every area of transportation soon will be affected by generative AI one way or another. Not always necessarily in a positive way, but yeah. But
Sure.
that,
Yeah,
yes.
I guess that's what I'm trying to get to is that like it's become like a finance buzzword, and it's very motivating to people who are filling out grants and things like that. But like surely there's something that's kind of like underrated, right? Like there's probably these things systems are really good at parsing large amounts of data, but they're also good at prediction and things like that, you know? So like if you had a $5 million grant, like where would you be exploring?
Well, well, here kind of I'm biased because first of all, I'm working with a relatively small subset of generative AI,
Hmm.
large language models dealing with the text data. We're trying to use with work with images, but I have not done very significant research there. And and in a small world of payment engineering, actually, the use of LLM is very difficult because the fundamental strength of LLM becomes a fundamental challenge. Let's say, I would
Hmm.
say, uh, LLMs are fundamentally probabilistic tools. As engineers, we would like to get deterministic answers. For example, if you ask what should be the concrete cover of, of reinforcement in reinforced concrete, and if you don't provide enough context, LLM can scan its database and see like people more often than not say it's 2 inches and give you an answer 2 inches. And it might be correct for 60% of the cases, but it might be totally wrong for your particular case. So, so this is, of course, you can fight with this by if you use an API by reducing temperature, but it will make it less creative, a little bit more deterministic. But I'm not sure that it's the right way to fight with the problem. The real issue is to teach LLM to ask follow-up questions and to make sure that it has all the information it needs to answer the question correctly. So and that um, um, problem making it can probabilistic LLM, more deterministic in a very narrow field with a lot of local information, like domain information and expertise required. That's a big challenge. but another important issue, it's kind of unrelated. It's not related to grant. Regardless of what we need to teach students is how to use LLM appropriately, how to check the results. So understanding is that you will not trust everything what you read on the internet. So why should you trust LLM that was trained on the entire internet domain that it will necessarily produce a correct answer? So that's regardless of this. It's more for the user for the for the users. But for me, the more challenging problems in LLM getting deterministic answers. So basically, the exact answer, not probability is not sufficient. And don't take me wrong. Sometimes probability is great. So we not always need the exact answers, but if we need it, it should be provided in exact.
Yeah, that's really fascinating. I think it's very interesting that you're identifying this kind of tension between deterministic precision and flexibility and creativity that seems baked into the very architecture of how these systems work.
Yeah.
I'm curious if you think that some of these smaller models seems to maybe a way out of that, right? Like something that is very like case specific to, say, the field of pavements in your case.
Well, I'm glad that you asked it because that's exactly what we're working on right now. Because there is another, well, partially caused by another issue. Uh, let's say payment field is a payment engineering field that I'm trying to concentrate on is a relatively narrow, like like a like point, like small point on the huge map of knowledge. So
Mm.
when big players like Google or OpenAI release new model, improve their model, it might work better for 99.9% of the population, but it's not necessarily works better for small payment community. So, and we had that issue. So when we submitted previous TRB paper, we perform we got the review back. We repeated an analysis, and we found for one LLM, that case was fortunately was open source LLM, the accuracy dropped from 70% to 30%. And first we tried to find a bug in our code. It wasn't there, but fortunately we kept all the weights from used in the first analysis. So we performed our um, analysis with old weights, and we got again 70%. So what will happen? Microsoft for that open source model, improved model. General, the model became better, but it degraded the knowledge in the area where we needed it the most. So yes, open source models are very good, and on top of it, you can really fine tune it and adapt them to your specific problems. And in this case, um, there is no concern um, that force update will change the weights and change the results. It's one, or at least you can, if there is an update of the model, you can check it first before putting it in production for your purposes. And the second, in many cases, people are ready to give information to like uh, big players, so because they don't know how to use, especially if there like for construction safety analysis, there is a privacy concern. In this case, when we perform demonstration of some of our tools, we the first thing we do, we disconnect Wi-Fi. So just showing that it's not there. So it's totally local.
Mhm. I've seen in recent months that certain book releases, especially nonfiction books, will be paired with a sort of AI companion that's been trained specifically on the book that you can ask questions about it and things like that. I wonder if that's kind of how we manage the future of, as we were talking about earlier, like literature reviews and things like that. You know, like maybe the journal Nature comes out with their like companion chatbot that they can use to, help people sift through every nature journal ever published or something like that. And these kind of specific use cases, I think, will become the norm as we seek to operationalize them further.
Well, there is a it's a very interesting idea because here we utilize flexibility LLM to mm, to get a, like let's say a relatively ill-possessed question and try to get the most out of this, kind of translate it to to language that is more uh, like 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 more meaningful. For example, if you misspell the question or you
Mhm.
just misword it, uh, you and basically if it means wrong, but still remember in this it works really well when it's the answer is not very important. You just do it from curiosity, or there should be a strict disclaimer that it's just for your information only. Yeah, it helps you to find information, but still, you are responsible for interpretation of the results. Because let's like going back to this concrete cover, maybe it's too technical because if you if you don't provide enough context, then the answer might be technically correct, but incomplete or wrong answer. So it should not be the results from this companion should be treated as a ground truth. It's just a help. So that's but it will definitely improve productivity and helps to disseminate results more.
Mhm. Always the last question. Um, and I think this is particularly important given the subject of today is what advice would you give to young people who are at the beginning of the field of their careers or preparing to start? You work with young students all the time. People who want to use these technologies as they go about their academic career or their professional career. Like, what skills matter most? But just what would you tell them?
Well, first of all, embrace it. So, uh, as a person who started with a slide ruler, so it's a, in, I would look really strange that if I start using it like these days, because yeah, it's a the productivity is not there. So if you want to be productive, you want to be competitive, you should master these tools as soon as possible. But at the same time, remember that with that domain expertise will be even more important than now. Let's say in my field, like every person can run a finite element program because these days it's extremely simple, unlike the time when I was a grad student. Graphical interface make it like it's super intuitive. Interpreting the results is extremely difficult. The first homework I give in my finite element class is to run Abacus. I give specific instructions to make sure that the results are complete garbage, but they look very legit. Exactly the same happened with generative AI. So the fact that you got it, the answer is not correct. But at the same time, it doesn't mean that you have to uh, invest a huge amount of time now and put everything aside. I would recommend like a gradual approach. The, like learn about generative AI, its basic principles. But what's more important, find right application, right program, learn how to apply it. Ask yourself question, what are the most time-consuming, repetitive tasks you have? Try to automate them. If possible, if you have basic computer programming skills, learn how to use API. All the folks still now using chat boxes, but you should understand that if you use only chat boxes, you the limitations what you can do with generative AI. And equally important, learn that not all generative AI tools are equal. And even for based on the mathematics that behind them. So some of them are better for um, um, reinforce for like structural well, structural inputs, some are more creative, and on and on. And learn various prompting technique. And again, that depends on your generative AI tool. If for some tools, shorter prompt is better. For some tools like ChatGPT, you should provide as much context as you can. So, and finally, at least at the basic level, try to understand the math behind it. So, if just understanding that it's a probabilistic tool, that the understanding how it was trained, how it uses will help you to avoid major problems. But the question shouldn't be if you should learn generative AI. The question is how, when, and what are the best applications. But regardless of this, the most important skill you have to develop is question the answers. So identifying when the answer is right, when it's wrong. But it's similar the way how you use Word. If you spell check is great, but you shouldn't automatically accept all the changes just the word suggests you. At the end of the day, you're responsible for the document, not Microsoft Word. Word is a great tool that improves productivity, makes the document looks great, especially compared to people with handwriting as mine. But we're responsible for the context.